Hello everyone, I am Mrs. Shanti Chellaya, working as Assistant Professor in EC department. Now I am going to discuss AC characteristics in op-amp. The AC characteristic describes the op-amp behavior with varying frequency signals, focusing on frequency response, bandwidth, and slew rate. The key aspects of AC characteristics includes a decreasing gain at high frequencies, which is roll off at minus 20 dB per decade after a corner frequency. The key metrics are the gain bandwidth product GBW, which is constant, and slew rate, which limits the maximum output speed. The prominent AC characteristics are frequency response, which describes how the gain of the op amp varies with frequency. Gain decreases as frequency increases. The next parameter is the bandwidth, the range of frequencies over which the op amp maintains constant gain. The next parameter is the gain bandwidth product. It is nothing but the product of gain and bandwidth. It remains constant for a given op amp. The slew rate is defined as the maximum rate of change of output voltage with respect to time, and it is expressed as volt per microseconds. The frequency response of an op amp refers to how the voltage gain changes as the frequency gain. While a ideal op amp would provide the same high gain across all frequencies, the op amp behaves like a low pass filter. The range of gain with frequency is given in the graph. The low configuration and no feedback is given. The op gain is massive but only for a narrow range of frequency. The maximum gain offers 100 dB or more at 0 Hz. The break frequency is also called as corner or cutoff frequency, and this is where the gain drops by 3 dB and approximately 70% from its DC value. For any general purpose op amp, this is as low as 10 Hz. Beyond corner frequency, the gain decreases at a constant rate of minus 20 dB per decade or minus 6 dB per octave. When you add negative feedback to create a practical amplifier, you paid the gain for increased bandwidth. An op amp with 1 MHz gain bandwidth product used for gain of 10 will have close to bandwidth of 100 kHz. The gain drops at high frequency is primarily due to internal capacitance, which adds a small internal capacitor to prevent high frequency oscillation and ensure stability. The next parameter is the gain bandwidth product. It refers to the range of frequencies over which gain remains constant. It is measured between low and upper of frequencies. It is defined as the product of the gain curve is constant. It remains constant for a given op amp. The formula is given as gain into bandwidth. The specific frequency where the gain drops to 1 or 0 dB. For 741 op, the slew rate is the maximum rate of change of output voltage. It is defined as the rate of change of output voltage which changes per unit of time. It acts as the speed limit for the amplifier's output, determining how quickly it can respond to rapid changes in the input signal. It is measured in volts per microsecond. The definition and formula is given as below. Slew rate is typically measured in volts per microsecond and it is mathematically defined as slew rate is equal to dV of dt at maximum frequency. For a sinusoidal signal with peak voltage Vp and frequency f, the minimum required slew rate to avoid distortion is calculated as slew rate is equal to 2 pi f into Vp. So f refers to the maximum frequency at which slew rate is there, and the effect of slew rate can be improved by increasing the frequency or by high speed limitations. The effects of slew rate limiting are high frequency and obstructed of sharp and fall time. General purpose I741 IC is very slow, typically in the order of zero point 0.5 volt per microsecond. High speed op-amps can exceed 1000 volt per microsecond. The primary physical limit of signal option we should know what is the rise time and settling time now. Rise time is the time taken for output to rise from 10% to 19% of the final value of the amplitude. Settling time is the time required for the output of the split panorama, particularly to prevent unwanted oscillations when negative feedback is applied. This is because in internal op-amp stages have parasitic capacitance that create multiple poles, that is the point at the gain is dropped and the phase shift can reach 180 degree while the gain is dipped, then one turn the head feedback into positive feedback. This leads to instability. So the frequency compensation follow to maintain stability, the gain margin and the margin. That's of internal compensation and the external compensation. Internal compensation in one op-amp L741 they are internal compensated on chip. External compensation is of two types. One is dominant pole compensation and pole zero compensation. So the dominant pole compensation includes a pole, that is RC network at the output to force the gain roll off before stability occurs. Zero compensation acts as zero to cancel the traffic pole effectively, extending the stability. The phase define dynamic performance of op-amp, and it is important for signal amplification and stability. It also offers reduced bandwidth, which drastically lowers the open loop bandwidth to ensure a safe phase margin. Reduced slew rate, the compensation capacitor must be charged or discharged by internal current, which limits how fast the output voltage can change. The phase margin, the design is